So let's start going through this. For number 1, it says write the system as a matrix equation and then solve that matrix equation by hand. So the matrix equation, when we write that, we're going to have the coefficients matrix times the variable matrix equals the solutions matrix. So that's the matrix equation. And in the notes, we showed you guys that the solution to one of these matrix equations is always going to be the inverse of the coefficients matrix times the solutions matrix. So that's the part that I'm going to compute by hand. We know how to calculate an inverse of a 2 by 2. That's going to be 1 over the determinant. So negative 3 times negative 5 is 15. And then minus 2 times 6, which is 12. Times the rearranged matrix. So the main diagonal, we switch the entries. And on the other diagonal, we switch the signs. And now I have 3 things being multiplied together, right? One of those things is a scalar multiplication problem, and the other problem is a matrix multiplication problem. It doesn't really matter which one you do first, but it's certainly going to be easier if I do the matrix multiplication before I do the scalar, because it lets me avoid having to add fractions at any point. So that's what I'm going to do there. So my first entry is going to be row 1 times column 1. So that's going to be negative 5 times 13, which is 65, plus a negative 2 times 24, which is minus 48. Oops. Still have that 1/3 out front. Forgot to write that. And then my second entry is going to be row 2 times column 1. 6 times, or negative 6 times negative 13 is 78, plus a negative 3 times 24, so that's minus 72. So that gives me 1/3 times the matrix 17 and 6. So when I do that scalar multiplication, I get 17 over 3, and then 2. So I can say x is 17 over 3, and y is 2. That's a 6. We were talking about that right there. Is a 6. 78 minus 72 is 6. I did the scalar multiplication. 1/3 times 17 is 17 over 3, and then 1/3 times 6 is just 2. This was the most in-depth one that we had here on the homework. Everything else, we're just going to use the calculator to do all the heavy lifting, but I think it's helpful and informative to do what the calculator is doing by hand once, just to kind of get a feel for what the calculator is doing when it does that. Which is not so bad, right? If the system was bigger, this would be more problematic. But for right now, for a small system, it's not too bad to do that by hand. We ready to move on to number 2? Okay. So let's set up our system. So again, we have our coefficients matrix times our variable matrix equals our solutions matrix. And then at this point, I'm going to go to my calculator to solve this. So I'm going to go ahead and enter in matrix A, or the coefficients matrix into matrix A. You can see I've already done that in advance of the class. And then in matrix B, I'm going to type in my solutions matrix. Again, you can see that I've already done that in advance of the class. And so what I'm going to do then is I'm going to go to my matrix, select matrix A, get its inverse, and then multiply it by matrix B, and press enter. So that tells me that x is 118 and y is negative 205. Yeah, Tom?
When you write the equation, what does that actually say? And why do you need that?
Why do I need that?
Yeah.
So remember that the solution to any matrix equation is going to be the coefficients matrix inverse times the solutions matrix. We're just not writing all the algebra to get to that because it's the same algebra every single time. But once we have that equation, we know its solution is the coefficients matrix times the solutions matrix, which is all I did on the calculator to get the answer. So I just was following the directions because it said to write the matrix equation. Right? Write this is a matrix equation, and then solve it using your calculator. So that's all I did, was I just followed the directions that I gave in the problem. Does that feel okay?
Yeah.
And you see how the equation relates to the answer?
Mm-hmm.
Okay. Justin, you had your hand up.
So for the A, you put in, for A, B, and C, you put in, what you
So I don't actually make the solutions matrix as a matrix in my calculator. Because if you look at this part in green, I just know that the solutions matrix is equal to the coefficients matrix inverse times the solutions matrix. And that's all I need to solve. So this, what I got here on my calculator, is actually what that x matrix xy is equal to. That's how I can conclude that x is 118 and y is negative 205. Does that make sense? I did this, A inverse times B. Caden? Uh-huh. Okay. Okay. It's probably just a little arithmetic error somewhere in there. Because what you're describing doing would have worked. And it's correct in practice. So that the only issue there that could have happened is like you made a little arithmetic error somewhere, like you copied something down wrong or something like that. But it would absolutely work. What you're describing would work, and there's nothing wrong with what you've done there, other than like something silly along the way kind of thing. Tommy?
Why do you think the inverse again?
That's how you had to get the matrix xy by itself. Is you had to move that to the other side, but there's no division for matrices. What we can do is multiply both sides by the inverse, and that basically does the same thing. Always. Okay? Ready for 3? All right, so again, we're asked to write this as a matrix equation. So, just like before, I'll start by writing my coefficients matrix. Times my variables matrix equals my solutions matrix. And then I can solve this, or I know the solution to this matrix equation is just going to be the inverse of the coefficients matrix times the solution matrix. And I'm going to do that part on my calculator. In fact, we'd have to do it on the calculator. We haven't talked about how to find the inverse for a 3 by 3 matrix, and I would not ask you to do that without using the calculator. In this course, it's beyond the scope of this course how you would do that. So we'll go ahead and enter in our coefficients matrix. I did that before the start of this class. I put that stuff into matrix C. And then I put the solutions matrix into matrix D. Everybody's good with that? So in my calculator, all I need to do is type C inverse times D. And that tells me that my solution is x equals 0, y equals 0, z equals -3. Everybody okay with that? Again, not too bad there, right? Four, we're asking you to do something different. Here we're asking you to use Gaussian elimination and to write the augmented matrix. So this one should actually be a little bit easier because there's only one matrix to make in our calculator. So the augmented matrix is basically exactly what we see. We've just removed the variables and the addition, subtraction, equal sign kind of stuff. Everybody's good with that? That's my augmented matrix. So I'm going to go ahead and then enter that in. I put mine into a matrix E. You can see it right there. I did that before the start of class. You can't see the fourth column because it's off the screen, but trust me, it's there. And then what am I going to do with that matrix? Well, I'm going to go to the matrix menu. I'm going to go to the math tab. And then I'm going to use the command RREF. And I'm going to do that on that matrix E that I just made. Row reduced echelon form. That's what the algorithm the calculator uses to do the Gaussian elimination. So that's just telling the calculator to do the Gaussian elimination on that. It's a little bit more to it than that, but it's beyond the scope of this class. Now notice I'm getting this crazy decimal here. It's probably going to be more convenient for me if I have this written as fraction. So I just did the math button and then the frac command. So this is the result I get from my calculator. All I need to do now is to interpret this to come up with my solution. Which part of this is of interest to me? The last row. What is the last row saying? Yeah, the last row just says 0 is equal to 1. So I know this is no solution. And I'm done. Nothing more for me to do there. Yeah, so the last row that says 0, 0, 0, 1 says 0x plus 0y plus 0z is equal to 1. Right? So that just means 0 is equal to 1, which is no solution. That's nonsense. Everybody okay on that one? Okay. Let's do 5 then. So again, I'm going to start by writing my augmented matrix, which again is pretty easy to do, right? Nothing tricky about doing that. I'll then go to my calculator. I've already entered this matrix in before the start of class, so here it is in matrix F. So I'm just going to do then that RREF command on matrix F. Again, I'm getting some kooky decimals here, so I'm going to use the math button and then select the fraction command to have the calculator rewrite this as fractions instead of decimals. It makes my life a little bit more convenient as I can see the whole matrix and it's not hanging off the end of the screen. What part of this matrix catches your eye here? The last row. What does that last row say? 0 equals 0. That tells me that there's infinitely many solutions, right? But we don't stop there because we also want to be able to describe the general form solution. And I can do that using the row 1 and row 2. So if I take a look at row 1, what that says is 1x plus 0y plus 21 over 11z is equal to 18 over 11. Right? If I look at the second row, that says 0x plus 1y plus 15 over 11z is equal to negative 17 over 11. Everybody okay with that? And how I got that? Using the first two rows of that matrix. Okay. So all I'm going to do now, I notice that both x and y I can write in terms of z's. So I'm just going to get the x by itself and the y by itself. So if I do that, I get x equals negative 21 over 11z plus 18 over 11. And similarly, I can say y equals negative 17 over 11z minus 15 over 11z. Everybody agree? Just by subtracting the z parts to the other side. Right? So, what I can do then is I can say that my general form solution for x is, I know x is equal to negative 21 over 11z plus 18 over 11. And I know y is equal to negative 15 over 11z minus 17 over 11. And since both of those are written in terms of z, z is like my independent variable, so z is just going to be the one I get to choose. So there's my general form solution. When I use, so you don't have to do that. It depends on kind of what you've solved one variable in terms of the other. For problems like this, where you're using the Gaussian elimination, more than likely you'd want to solve the x and y in terms of z's and leave the z at the end. But you don't necessarily have to do it that way. But it's probably easiest to do it that way more often than not. Yes, John. Oh yeah, it doesn't matter the order. As long as the signs in front of the things stay where they're supposed to. Because addition and subtraction, like addition is commutative, right? So that part doesn't matter. Justin's asking like why I switched the order here, and I didn't really realize that I did do that. I just wasn't paying attention. But it doesn't really matter. Do we feel okay about that one? Okay. We have one more here. So again, we'll start by writing our augmented matrix. Now notice here on this second equation, I don't have a z, right? Everybody see that? So if I'm missing one of the variables, I'm going to put a 0 in the spot where it's missing. So I need to make sure that 0 is in line with the other z's in the other equations. Yep, there's one more problem on the back. Should have been a Q at the bottom of the first page. It says 1 of 2. So that was a giveaway there. Yeah. Sure. So there's my augmented matrix. So just like before, I'm going to go ahead and enter that into my calculator. You can see that I did that before the start of class. And then I'm just going to do RREF on that matrix. gives me this. And how do I interpret this result? Oops. I can just say x is -5, y is -5, and z is 0. Or z is 3, right? Everybody's okay with that? So just to be clear here for everyone, when it comes test time, will you have to be able to use your calculator to do these? Yeah, it's my plan, at least in my head right now, is I would probably only ask you to solve like one 3-variable system and one 2-variable system by hand, because that's a time-consuming process. But I might ask you to solve lots of other systems using your calculator, because that's much, much faster, right? Like we did 7 of those problems in like, yeah, it was not, I mean, it's like a minute a problem is not unreasonable kind of thing with using your calculator. So I can ask a lot of those kinds of questions where solving a 3-variable system is like a 10 to 15-minute problem, right? I can only ask that so many times. Okay? Tommy?
When you load up the equation, how can you separate the 6 and 5 and 12?
So this is a different process. So we have 2 different solving systems processes using a matrix or using matrices. One is using the Gaussian elimination. That's where we use the RREF. And the other is using a matrix equation. That's where we do A inverse times B. Okay, so they're just 2 different processes. That's why one of them, the Gaussian elimination, uses just the single matrix that you do the RREF on. The other one uses the matrix equation where you really have 3 matrices and you're solving for that variable matrix. Does that make sense?
Yeah.
Okay. So the directions there really told you why I'm doing something different. Okay with that?
Yeah.
Okay. So the last topic that I want to talk about here is some application problems. So the first situation is going to be like a story problem situation. so let's say you're selling some raffle tickets for a fundraiser. People can either buy one ticket for $2 or buy a 3-pack of tickets for $5. Let's say you sold 83 total tickets for $307. And we want to know is how many single ticket sales did you have and how many of those 3-pack ticket sales did you have. So the first thing that I would do in a situation like this is I would assign a variable to represent each of the two quantities we're interested in. So maybe I'll use S for the number of single tickets and T for the number of 3-pack tickets. Everybody okay with that idea? So far, so good? And now what I'm going to do is write a system of two equations to describe this situation. Everybody's okay with that idea? Okay. So what I need to do is I need to figure out two equations that I can write from the given information. Well, let's start out by looking at the information that we've been given. I know I'm given two totals in this problem, right? 83 total tickets sold and $307 collected. Everybody agree with that those are two separate totals? So those are going to be used in two separate equations. Hopefully it's easy to see that. What kind of equation can I write with that 83 tickets sold? What was that? Okay. What do those 83 total tickets include? Both sets, right? So if you knew the number of single tickets and you know the number of 3-pack tickets, how much would that be? It would be 83, right? So I can say that. And then let's say we wanted to, the other total we know is the 307, right? How did I get the 307? Okay. So I'm going to have money from the single ticket sales, right? And it's $2 per single ticket, right? So if I sold 15 tickets, single tickets, how much money would I have expected to get? $30, right? Everybody agree with that? So 2 times the number of single tickets sold. Everybody agree with that? Okay? If I sold, 8 3-pack tickets, how much money should I have collected? 40, right? So 5 times the number of 3-pack tickets sold. And that should all be 307. Everybody happy there? That's my system. How should I solve that? Well, I'm going to use my calculator. And which method for my calculator do you want to use? I'm going to do Gaussian elimination, man. It's the easiest one, I think. So that's a 2 by 3. If the directions tell you not to. But it'll always work. But the only time I wouldn't use it is if the directions told you to do something else. But if you can use your calculator to solve the system, that's all I would do, man. So I get that I sold 36 single tickets and 47 of the 3-pack tickets. Cool? So it's solved for S&T. Right? Yeah. Yeah. Julia. The single tickets cost $2. The 3-pack tickets cost $5. Okay? What do you guys think? What's the hardest part of this thing? Writing the system, right? Once you got the system, it should be easy to do. The calculator will handle all the heavy lifting for us. So the next application we have is if I ask you to write the standard form equation for a quadratic. Ty, what's up? Sure. So let's say we wanted to write the standard form equation for the quadratic that passes through the points -3, 53, 2, 13, and 7, 123. Well, let's start by reminding ourselves what the standard form equation for a quadratic looks like. Who remembers what that is? That was just a chapter ago. We should still remember that. What was that? No, you're okay. I think you were saying the right thing. You're just quiet, and I couldn't hear it. Everybody okay with that? We remember seeing that now. At least it should look familiar if you didn't remember that right from the get-go. So if I'm able to write my standard form equation, what 3 things do I need? You need a value for A, B, and C, right? That's 3 variables, so I'm going to need how many equations? 3 equations. Everybody good with that idea? Okay. So what am I going to do? Well, I have a bunch of x's and y's here, right? So all I'm going to do is plug those x's and y's into that standard form equation. And that'll give me 3 equations in terms of A, B, and C. So the first, if I plug in the point -3, 53, I'd get that equation. A times -3 squared plus B times -3 equals 53. Everybody okay with that? That's just using the first point here. And now I'll just do that 2 more times. So if I use the point 2, 13, I get that equation. If I use the point 7, 123, I get that equation. And there's my system. How do you want to solve this system? Yeah, let's do that Gaussian elimination. So I'll go ahead and type this into my matrix. So I need a 3 by 4. What's the first coefficient going to be? -3 squared is 9. And my next coefficient would be -3. And then my third coefficient would be 1. And my last value is 53. And then I would just do the same thing for each of these rows. Just going down, doing the same thing. Everybody okay with how I entered that in? Yes, sir? Sure. And then we'll just do the RREF on that matrix that we just made up. So what is that matrix telling me? Well, it says that A is 3, B is -5, and C is 11. So the equation I'd write is y equals 3x squared minus 5x plus 11. So you go to the matrix menu, and then you go to the math tab, and it's down towards the bottom. So just keep scrolling down until you see RREF. Yep, you press enter, it puts it back on the home screen, and then you just go back into the matrix menu and pick the matrix you want to do it on. Yep, and then press enter, and that's all you need to do. Should be pretty easy, right?
Yeah.
Yep. Tommy. Yeah, so if I look at the first row, that's 1003, right? That says 1x plus 0y plus 0z is equal to 3. So 0 times y is 0. 0 times z is 0. 1 times x is x. X plus 0 is just x equals 3. And I can do the same thing for each of the 3 rows. So when you do the RREF, you're always going to get ones down the main diagonal, like that. The only occasion where that wouldn't happen is if you have no solution or infinitely many solution. But if there's a single solution like this, it'll always kind of line up and be in order for you. So you don't have to think too hard about it. Yep. Unless you entered your matrix in like for your variables in like a weird order or something, but should be fine. We okay on that one? So again, not too bad, right? I think even easier than the previous one because getting the system is much easier to come up with than the story problem where you actually have to kind of think about what's going on with it. And the last one, this is a matrix problem and not a system, or matrix application, not a systems application. So if you wanted to calculate the area of a triangle, but instead of given a picture, you're just given the coordinates for the 3 vertices for the triangle. When we say vertices of a triangle, what are we talking about? Yeah, the tips at the end of the triangle, right? So let's say So let's say we want to calculate the area of the triangle with vertices -3, -7, 2, 10, and 6, -1. Now in your geometry class, you probably learned how to do this, right? What would you want to be using if you're in your geometry class to calculate the area of a triangle? Yeah, does anybody remember what that equation is? Yeah, 1/2 base times height, right? So, okay. All right, I kind of remember that. So maybe I'd graph these things. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So I have -3, -7. 2, 10. And then 6, 1. Okay, so that's my triangle. I have 1/2 base times height. Now what? Which one of these sides is the base? You're saying this one here? No? This one? This one. Okay. Sure. Any of them can be the base. Then what's the height? No. You need that one. So we can calculate the length of the base, and that's not too much trouble. What would you have to use there? You just use the distance formula to calculate the length for B, right? How are we going to figure out H? Well, how do you know where it intersects B at? This is a problem. So you'd have to find the perpendicular, through this point, then find where it intersects B, and then find the length using the distance formula. That's a heck of a lot of work. That stinks pretty bad. Is there a better way to do this? Yeah, you would think at this point that there must be a better way. There is. So the area of the triangle is plus or minus, 1/2 times the determinant of the matrix x1, y1, 1, x2, y2, 1, and x3, y3, 1. So that's what we'll do instead. So notice that we've substituted all of that geometry for one 3x3 determinant. I'd say that's a pretty fair trade, right? Okay. So let's go ahead and enter that in, because I'm going to just use my calculator to do this. Let's see, so 3x3. Let's see, the first point was -3, -7, and the last column is a 1. Then I have the point 2, 10, and the last column is a 1. And then I have 6, -1, and the last column is a 1. Lee, what's up? Sure. So now I'm going to do 1/2 times the determinant of that matrix. To get the determinant command, I'm going into the matrix menu and going to the Math tab. So that gives me -61.5. Should an area be negative? No, right? What part of the formula haven't we done yet? We haven't used the plus or minus. In this case, which one should we be using? The minus. Why should I be using the minus? So that the area is positive. So the plus or minus there, you're going to choose to use whichever one is going to give you a positive answer for the area. So this plus or minus in our formula is really the same thing as what? It's really basically an absolute value. But I didn't want to use an absolute value in this formula because with the determinant in there also, that really feels like we're abusing that vertical bar notation. We're using it as two different meanings in the same formula. So I didn't want to do that, so that's why I put the plus or minus there. But you're just using the one, making it positive or negative depending on, you just need a positive answer for the area when you're done. Yeah, Tom? Sure. Everybody feel okay on that? Well, that's it, guys.